Okay, this is video 2. I wanted to talk about reactions of carboxylic acids. Now, there's really only 3 reactions you can do with a carboxylic acid that we've learned here in the Klein textbook. Let me sketch those out for you here. Um, if we have a carboxylic acid such as this one here, what would the name of this be? Let's see. We would call this butanoic acid with a U. Okay. We can treat this with 3 different reagents, okay? As I've mentioned, you can treat this with thionyl chloride. Okay, thionyl chloride will convert the OH of the carboxylic acid into a chlorine there, okay? And we call this functional group an acid chloride. We would name this based on the carboxylic acid. So this is butanoic acid, and we would name this butanoyl chloride. So you remove the ic acid, and it becomes butan O, okay? And then you add YL chloride, okay? So you remove the ic acid and you add YL chloride, and the name of that is butanoyl chloride, okay? Pretend like you're eating sushi or something and you're pronouncing it butan, oh, it's eel. Okay, butanoyl chloride. That's exactly how it's pronounced, okay? Now, another thing that you can do with the carboxylic acids is treat them with lithium aluminum hydride, okay? In some textbooks, this is written LiAlH4, step 1, and step 2, water, okay? So if we do that, we keep the same number of carbons and we convert the carboxylic acid into a primary alcohol. It's always going to be a primary alcohol, okay? And the name of this would be 1-butanol, okay? Another chemical, so you don't need to know the mechanism for this or this. You just need to know the synthetic procedure there. Butanoic acid, when you treat this with alcohols, they could be primary or secondary or tertiary. One of the labs I'm going to do for you is treat a carboxylic acid with alcohol in the presence of a catalyst, an acid catalyst, and we're going to look at the products that form the equilibrium constant and things like that. So here I'm going to add propanol, and it's going to be H+, okay? H+ catalyst. So what you get from this chemical reaction is an ester. Okay, so these 4 carbons come from the carboxylic acid. Most often we draw an ester like this with the carbonyl on the left and the alcohol portion kind of on the right. And so these 3 carbons come from the alcohol. So we always draw it this way, but we name it kind of backwards, okay? So the name of the acid is butanoic acid. And the name of the alcohol that we used to make it was propanol. 1-propanol, I'll just say propanol here. So to put these 2 names together, we would arrive at the name propyl butanoate. Okay, so you take the alcohol. Let me highlight this, I guess. So you take the ending of the alcohol, okay, as well as the AN part of the alkane. Okay, so you take prop, and then you add YL to that. Okay, and then butanoic acid becomes butanoate. So you take that ic acid and you throw it away again, and you add 8. All right. So let's name another one. Okay. So when you're naming these, you need to think carefully about how many carbons you have. There's 2 here. Okay. So we could call that one of 2 things. We can call that ethanoic acid, or its common name, acetic acid. Okay. And then here we've got a very long chain alcohol. 1, 2, 3, 4, 5, 6. So that's hexanol. So we start with the alcohol, and it's going to be called hexyl. And then we switch over to the acid, and we're going to chop off the oic, right? And it's going to be ethanoate. We chop off the ic acid only part. Okay, ic acid. So that's going to be F and O8. Okay. So for your homework, for your practice, try to name these carboxylic acids. Okay. So we'll call that A and B. Okay. Now I forgot to mention it, but there is one other thing you can do with carboxylic acids. If I come back up here to the top summary page again, you can take this and you can treat this with sodium hydroxide. And this will produce the sodium carboxylate. Okay. These are neutral molecules, and oftentimes they have more than 4 carbons, and they might be water insoluble. But the carboxylates are ionic, and they're all going to be, water soluble if you do decide to dissolve them into water. So the name of this would be sodium butanoate. Okay, same number of carbons, you just formed the carboxylate. Okay, so this is called a carboxylate functional group. All right, so let's do a couple of reactions with the esters. So again, we can take any old carboxylic acid we like in this case benzoic acid. And we can treat that with an alcohol. Under an acid catalyst, and we want to draw the products. So what you want to do is remove one of the OHs, okay, and connect this dot to one of the carboxylic acid OHs. So basically this dot is going to connect right to that oxygen. So the pattern that you get here is you draw your carboxylic acid without the hydrogen, and then what you want to do is attach these carbons right here, and you'll notice the dot there. Okay, so that's 1, 2, 3, 4, 5, 1, 2, 3, 4. So that would be 5 carbons, okay? Let's do another one. Sometimes your alcohol might be quite complicated looking. And your carboxylic acid might be quite simple and more easy to draw above the reaction arrow. So this is just swapped, but it's still A plus B. We've got an alcohol and we've got a carboxylic acid. So you could draw however you like. You could draw it like with the alcohol here. Okay. And then here's your carboxylic acid, right, without the hydrogen. Okay. Or you could draw it flipped around if you like to think that way. So here's your carboxylic acid without the hydrogen, right? Here's acetic acid without the hydrogen. And then you want to bond that to your alcohol, to this dot here. And you need to make sure that you grab all the same number of carbon atoms and hook this guy up. Okay, so you could draw it like that if you like. But count your carbons, make sure you have the correct number of carbons for the alcohol portion and the correct number of carbons for the carboxylic acid. Okay. There's a nice little problem that I located in the textbook here. And this is problem 2122. Let me just go ahead and take a picture of it here. All right, and some of these reactions we didn't review yet, but we have talked about them all. It's basically saying, hey, you can go from this carboxylic acid to this ester here, and there's 3 different ways to do it. Show how you would do it, okay? So, there's going to be 3 answers here. Okay, A, B, C. Purple doesn't show up very well on a black background, so we could take our carboxylic acid, as we've just been discussing, and we could try to figure out, how many carbons the alcohol must have. And so what we can do is react this with ethanol, ETOH, you could write it. Don't forget the acid catalyst, and that would form the ethyl ester of our benzoic acid. Okay, you could write this OET or with those 2 lines there. Okay. Now another way that you could make the ester is to first transform this to an acid chloride. And as I mentioned, the acid chloride is like an international airport. From there you can synthesize many other molecules of your choosing. The way to do this would be to add ethanol. Okay, and that would also give you the target molecule there. Okay. Now a third way that you could do this chemical reaction is, at the moment I'm drawing a blank here. I'm thinking maybe they're thinking you can go from an anhydride or something. I'm not sure what they're really looking for. So, but these you should know for sure at this point, right off the tip of your tongue type of thing. Okay, so we'll stop this video here. What we've discussed are basic reactions of carboxylic acids, and we've talked about acid chlorides. We've talked about esters, and we haven't reviewed reductions too much with this LAH, but that's a very basic, just 1-step reaction. Okay.